Be able to identify types of scales and projections used in map making. Identify advantages and disadvantages of different projections. Before going into depth of scales and projections, let's first look at their definitions. Definitions. Generally, scale is the relationship between the portion of Earth being studied and Earth as a whole. The definition of projection is the scientific method of transferring locations on Earth's surface to a flat map. A specific type of scale is map scale. Map scale can be presented in three ways. Those are a ratio or fraction, a written scale, or a graphic scale. A ratio or fraction shows the ratio between distances on a map and Earth's surface. An example is seen below. This states 1 to 4,800. Therefore, this means that 1 unit on the map represents 4,800 of the same units on Earth's surface. A written scale shows the relationship between distances on maps and distances on Earth's surface. An example is seen below, which is 3 inches equals 10 miles. Therefore, 3 inches on the map represents 10 miles on Earth's surface. Graphic scale is usually a bar line which shows distances on Earth's surface. Let's say you were going on a trip from point A to point B and you wanted to calculate its distance with a bar line on a map. To calculate that distance, you must get a ruler and measure it with any unit. That could vary from inches to centimeters. Once you have calculated that distance with that specific unit, memorizing that measurement, you then put it on top of the bar line and measure it depending on the distance between the 2 points. So for example, the distance between A and B was 2 inches. We then put it against the bar line and we calculate the distance which it would be on Earth's surface. In this case, 2 inches would translate into about 230 miles. A large-scale map shows a small portion of Earth's surface but provides tons of details of a specific place. A small-scale map shows a large portion of Earth's surface and can easily show features on Earth that affects a large population. According to infoplease.com, many projections are made using light sources. Light sources are able to project the features of a globe onto a flat surface, in this case, a piece of paper. It also states that many projections are made mathematically. Moving into specific projections, we start with the Robinson projection. The Robinson projection is great for displaying information across the ocean. Unfortunately, the land areas look much smaller when compared to other maps of the same size. Mercator projection. The Mercator projection distorts shapes very little, direction is consistent, and the map is rectangular. Unfortunately, land masses towards the poles of the Earth look much larger than their actual size. Equal area projection. The equal area projection is great because the shape of land masses are distorted very little to the point where they are the same as in reality. Unfortunately, interruption occurs and the meridians do not connect with each other at the North or South Pole. Nor did the meridians make right angles with the parallels.